inequalities. So first of all, the first section or first part of this, you are going to be writing inequalities from words, right? So the one thing I want to tell you is your inequality signs, in order from words, an inequality sign has to have the word is. All right? Inequalities? Yeah. No. From words. The key word is. So if I have the expression is less than, it is an inequality sign, right, with the point going to the left and the alligator eating the right. Is less than. Now, if I don't have the word is there, less than just means what? Subtraction, exactly. Okay, so you have to have the word is in order for it to be an inequality sign. How about is greater than? It's the other way, exactly. Oops, that's not the other way. Let's try that again. All right. Okay, so I just want to show you the first couple problems you have in your homework. That's what you have to do, is you have to write something, write an inequality from words. So this is 10 and 12. So let's say 5 less than a number is greater than 7. All right. So is greater than is our inequality. To the left or before our inequality, it says 5 less than a number. Well, that's a flip-flop because of the word than. So we actually get n minus 5. Our inequality sign is greater than, and then, of course, the right-hand side or the other side of our inequality sign is just a 7. Okay, so you have 2 problems. That's all you have to do. Any questions on how to write that stuff? Okay. All right, next thing I want to talk about. Does anybody have a question on how to solve an inequality? Okay, so when we solve, there's one special rule that's different from an equation. What rule is there that's special? Whoops, that's supposed to be a star. There we go. What is a special rule when we're solving for an inequality? Yeah. When you divide by a negative, technically it's when you multiply or divide by a negative. The sign flips. All right. The other thing I want to talk about is graphing it and interval notation. So these books are old. As you can tell, they're quite old. And so they're not up to date on all the terminology. So your books do not ask you to do interval notation. Anytime your book says graph it, you have to also do interval notation. Okay? So let's talk about what that means. All right. If I have x less than 4, the sign, that's supposed to be an I. There you go. If I have x less than 4, on my number line at 4, because it is just less than, I have an open dot, and my line will go to the left. You'll notice the arrow on my line and the inequality sign look the same, right? The interval notation, because you're starting at the arrow, it starts at negative infinity, goes all the way to 4, and when it's an open dot, it's a parenthesis. Correct. Very good. If I have x is greater than 3, on my number line at 3, I have an open dot because it's just greater than, and it goes to the right. You'll notice again the greater than and the inequality sign the inequality sign and my arrow are the same direction. My interval notation this time starts at 3, and the arrow goes forever to the right or to positive infinity. If I have x is less than or equal to 7, on my number line, because it's less than or equal to, I have a closed dot, as Chase said. And again, it's less than, so it goes to the left. The interval notation starts at negative infinity, goes to 7 with a bracket. Many of you have already remembered that, which is excellent. And the last one we have is if I have x is greater than or equal to 5 on my number line at 5, because it is greater than or equal to, I will have a closed dot. And it will go to the right. My interval notation then this time starts with a bracket at 5, and this goes all the way to infinity. Are there any questions on interval notation? Okay. So we're going to go to example number 2. Are you ready? Okay. All right, example number 2. This is going to cover problems 14 through 26. It says solve and graph. And if you are graphing it, even though our book does not say it, you have to do interval notation. All right, so let's start with this one. Let's say I have 3 times x plus 4 is less than or equal to 9. I don't know. All right, so to solve this, it's just like an equation, right? First, we got to get rid of the parentheses. 3 times x is 3x. 3 times 4 is 12, less than or equal to 9. Now I need to move my 12 to the other side, so I'm going to subtract it.
X is less than or equal to 1.
Good. Now I divide, and Chase is right. I divide by 3. I get x is less than or equal to 1. All right, so I've solved it. Now I have to graph it. All I ask you to do is on your number line, put the 1. Is it an open or closed dot?
Close.
I agree, because it's got that equals underneath it. And does it go to the right or the left?
Left.
Goes to the left. And of course, if we have to graph it, oh, yeah, I lost my negative here. Thank you. Thank you. Thank you. No, thank you. I lost it. It's my bad. All right, interval notation starts at our arrow, which is negative infinity, goes all the way to negative 1. And because it's a closed dot, it's a bracket. All right. Try another one. Example number 3. Go ahead. Go ahead. What's your question?
No, I need to stop.
Okay. Yes, that's when you divide by a negative. Yep. You're welcome. Okay. All right, let's do example number 3. Again, I'm going to ask you to solve graph and interval notation. So even though your book doesn't say it, you have to do it. All right? Okay, let's do this one. Let's say I have 3x plus 7 minus 10x is greater than or equal to, you want 5?
No, let's do 3.
3? All right, 3 it is. Whatever you want, Jace. Okay, so here we're going to go ahead and collect like terms. 3x and negative 10x is negative 7x plus 7 is greater than or equal to 3. Now I need to move my 7 to the other side, so I'm going to subtract my 7. So I have negative 7x is greater than or equal to negative 4. Now we're going to divide by a negative 7, and when we divide by a negative, what awesome thing happens? The sign flips. So this becomes a less than or equal to, and negative 4 over negative 7 is 4 over 7. When you get a fraction like that on your number line, I only need one dash, 4 over 7. Is this an open or closed dot? Good. Which way does it go? Goes to the left. My interval notation. Starts at negative infinity, goes all the way to 4 over 7, and because it's a closed dot, it's a bracket. Whoops, that's supposed to be a bracket. Not sure what that was. All right, so any questions before I go to my last example? Yes? Because right here, when you divide by a negative, anytime you divide by a negative, your sign's going to flip. Okay, because it takes everything that's on this side and puts it on this side, and everything that's on this side and puts it on this side. Okay? All right, one last example. So example number 4. Example 4. This has to do with 28 through 34. Is the inequality always, sometimes, or, excuse me, never true? And let's say I have negative 7 times 3x minus 7 is greater than or equal to negative 21x plus 50. Sorry, excuse me. All right, first thing we have to do is distribute. Negative 7 times 3x is negative 21x. Negative 7 times negative 7 is positive 49. Greater than or equal to negative 21x plus 50. We're going to move my 21x to the other side. What happens to my x's when I do that? They cancel, don't they? I have 49 is greater than or equal to 50. Is that true? Nope. So this is never. Or you can say no solution. Either one. Any questions? Awesome. All right, so here's the deal, you guys. Just so you know, I'm not going to be here the next 2 days. Okay? I will have all of this work worked out in detail in our folder on the desk. So if you have questions on how to do something, it will be there. All right? You're going to be doing a review assignment for the next 2 days. We're going to be fine. We're going to be great. If you need anything, feel free to email me, and I will get back to you as soon as I can. Okay? If you go to the Deckerville website, it's right on there. You can just click on me. Oh, yeah, or you can go to Google Classroom and send me a message, too. The bell's going to ring in like 3 minutes. Oh, I better stop that.